Dear students, now we are going to see the subject renewable energy system. Under that, the topic is thermal power plant. Thermal power plant which convert the solar radiation into a heat. The resulting heat energy acts as a thermal energy that is transformed into a mechanical energy by a thermal engine. Then this thermal energy is converted into electricity. For thermodynamic reasons, high temperatures are required to achieve the utmost efficiency. Such high temperatures are reached by increasing the energy flux density of the solar radiation incident on a collector. According to the type of solar radiation concentration, solar thermal power plants are divided into two. One is concentrating, that means it's focusing on a point. The second one is non-concentrating systems. So the concentrating system can be further classified into a type of receiver of the solar radiation, heat transfer media and the heat storage system, additional firing based on fossil fuel energy. Concentrating system concept, solar tower power plants as focusing power plant, dish or Stirling system as a point focusing power plant, parabolic trough and Fresnel trough power plant as a line focusing power plant. Concentrating collectors can reach temperature level similar to that of existing fossil fuel fired thermal power stations. Non-concentrating system concept that use a solar updraft tower power plant, solar pond power plants. So solar thermal power plant structure is shown in figure. So that the solar radiation is observed. This observed radiation is converted into heat energy. This heat energy is then converted into mechanical energy. This mechanical energy rotate the turbine. The turbine is connected with the generator. The generator generates the electricity. The plants produce the electricity that utilize the energy from the sun to heat the fluid to a high temperature. This fluid is then transferred to a heat water which then becomes superheated steam. The steam is used to turn the turbine in the power plant, and this mechanical energy is converted into electricity by the generator. The principle is same as the electricity generated by using a fossil fuels. Facts about solar thermal energy. Solar thermal energy has been used in number of ways, ranging from simple fire starting with a pocket mirror to solar architecture to capture in heat in buildings. It has an efficiency of 45%. It uses the 48% of infrared spectrum from the sun, which are invisible to human eye. The solar thermal collectors can employ nearly the entire solar spectrum. The solar process of solar thermal power generation, the concentrating solar radiation by means of collector system that increases the radiation flux density, and it also causes absorption of solar radiation which convert the radiation energy into thermal energy inside the receiver. The transfer of thermal energy to energy conversion unit, and this energy conversion unit convert it into mechanical by using a thermal engine or a steam turbine. The conversion of mechanical energy into electrical energy by using generator. Solar tower power station that has the main principle and components is in solar tower power station are central receiver system, mirror tracking the course of sun into axis, heliostatic reflect the direct solar radiation onto a receiver centrally positioned on a tower. In the receiver, the radiation energy is converted into heat and transferred the heat to the transfer medium. This is the overall structure of the solar tower power station. So sun radiation is collected in the heliostat. This collected radiation is reflected to the receiver. The receiver direct it to the tower. Tower convert it into the thermal energy, that is heat. Heat superheat the salt on a tank. Then it produces a steam. The steam rotate the turbine. Turbine is attached to the generator. Heliostat or the reflecting surface that provided with two-axis tracking system which ensure that the incident sunlight is reflected towards the target. The heliostat commonly concentrates the sunlight by means of a curved surface so that the radiation flux density is increased. It also consists of a reflector surface, example mirror or other sun reflecting surfaces. The sun tracking system provided with drive motors, foundations and control electronics. The individual heliostat's orientation is calculated on the basis of position of the sun, spatial position of the heliostat and target point. The target value is communicated electronically to the drive motors via the communication line. So this information is updated for every few seconds. The heliostat concentration is varies between 20 to 150 meters square. The largest heliostat surface amount is 200 meters square. This is the structure of the heliostat which is used in the thermal tracking power plant. Due to the economic consideration, the heliostat with surface ranging from 100 meters square to 200 meters square is possibly used. So smaller heliostat that can be used to reduce the cost by efficient mass production. Heliostat usually centrally controlled and centrally supplied with electrical energy. The energy required for the control processor and the driver is provided by photovoltaic mounted parallel to the reflector surface. So this is an example structure of the heliostat. Heliostat field. The layout of heliostat field is determined by the economic optimization, which is located closest to the tower present at the lowest shading. The heliostat placed north to the northern hemisphere, the lowest cosine losses. Heliostat placed far off the tower, by contrast, that require a high precise tracking depending on the geographic location, that have to be placed farther from the neighboring heliostat. The cost of the land, tracking and orientation determine the economic size of the field. Cosine losses that represent the difference between the amount of energy falling on the surface of the pointing at the sun and the surface parallel to the surface of the earth. Receiver of solar tower plant station transform the radiation energy. The radiation flux density is varies from 600 to 1000 kilowatt per meter square. Receivers are classified based on the applied heat transfer medium as well as the geometry of the receiver. According to the heat transfer medium, it is classified into water or steam receiver, salt receiver, open volumetric receiver, air receiver, closed air receivers. Water steam receiver. The first solar tower power station that is similar to conventional steam process. The water is vaporized and partly superheated into in a heat exchanger. Since the superheating is prone to unfavorable heat transmission and due to the fact that startup operation or a part load operation require complicated control, this approach is not developed further. So this is a steam water receiver system. Salt receiver, the heat transfer medium applied the secondary circuit should have a high heat capacity and good thermal conduction properties. Molten salt consists of sodium or potassium nitrate comprised with three requirements. The disadvantage is the salt must be kept liquid also during ideal time when there is no solar radiation. This is required to either heat the whole part of installation that is filled with salt and thus increases the energy consumption of the plant itself or to completely flush the salt circuit. Thank you.